I think it's working right now or not. Let me check the streamer now. Check the stream if it's. Let me get a second. Yeah, I think it's working. Okay, it's visible. Okay. So this lecture, this live session is a little bit of introduction to the language models that for or the diffusion models for image generation. And this live session will be one of the many sessions that we're gonna do to understand the image models and the language models and overall the current tech contents that is going around, more like LLMs, the diffusion models, how these current image generation models, how do they work, how do they process, how do we interact with them, and generally these live sessions will be about how to understand the LLMs and the token system and how to build applications with it. But first, we need to understand how these LLMs work, how these, a lot of concepts like MCP and the diffusion models that are image generators, it is just the early stages of development. So right now we're not seeing a lot many language models that are popular or that are decent. So this session, these series of lectures of live sessions that we will do, it started when I started experimenting with the Nano Banana, Google's new AI model. You can see they kind of it's very good. It's so good. Let me just give write a prompt and show you. Maybe short. Okay, let's run it. It's also fast. The main, the thing with this is the Nano Banana is that the model is very fast, whereas Flux, when we use it, it does take an let's say 20 to 30 seconds, but this model it's quite fast. The quality is also very good. You can see this is almost realistic. If you add a lot more details to the prompt, you can get a more realistic picture. You can try explaining the outfits and the angle and the background in more details, but this is doing a lot more, than the prompt has asked. This convoy and the images. Let's get back to it. So I was experimenting with it, and then I thought, okay, let me try something more, some prompts that can push, you know, the limit of it. And then uh, I entered this prompt, same prompt, but hitting the head of another mercenary soldier tied to the column bar, blood dripping from the. Then it hits a limit. It hits a restriction that I can't generate images. I cannot create visuals that depict violence against individuals. Okay, helpful. It gives me this notice. Okay, and then maybe I remove blood dripping, and then we'll try. And then this. Then again, it also blocked the content of violence. So I was trying this because I know I saw this latest TV series that came on Prime. That's Terminalist Dogfall. It's very good. You should see it. Then I was trying to write a scene of one of the action sequence that is in the movie, that is in the series, and then it keep getting content block. But then I just wondered, okay, how does it work that some words are restricted, but if I try to some kind of a play here, if try to do something, it might bypass, but most probably it will not. So I thought maybe we'll understand how this model works and then get more into how to train image model so that we can get more uh, restriction free content. These models, Flux and Stable Diffusion, Excel, and Quen. Also, there is new model Quen. I think it was also one more model. It was also Seed Dream 4.0. I mean, the Seed Dream was also good, but the quality of Nano Banana is just a whole new level. But how these restrictions are implemented? First of all, it does not filter the images. That content, it say, oh, I'm gonna this prompt ask me to generate this type of content and I'm gonna block it. No, it does not do that. It has certain prompt filters. So no, the Google team, they had engineered and trained this model on a lot of data. I mean, if there were no prompt filters and any restriction defined, I mean, if there were no restriction defined on it, we will be getting a lot more, misuse of this model. So they also did few fine tuning, but after the initial training, they can't really train the model on a way that, okay, you can see this image during training, that you can see this image. Do not try to generate this kind of content. No, it does not work like that. They train the model on very unrestricted content. I don't know, you can get into the gray area that they trained the whole model on a lot of context. I mean, it may be million of images. You cannot fine tune those images one by one. So they probably, you know, trained those models with unrestricted data that may have some, NSW stuff. So after the training of the initial model from scratch, they added prompt filters. That is this, this prompt filters. This came after the training. First of all, the model fine tuning happens after the initial training, and then the model is ready. Then the post generation filters. These are also after it. But let us understand how these restrictions are implemented in real time. First of all, when we send this prompt to the Google, it first of all checks our prompt, that is there any words, any kind of phrasing that can generate the restricted contents. It checks with the content that is restricted. For example, they may have said that no gore type of no and this kind of content. So that is implemented through prompt filters. And after that, the model has some kind of additional fine tuning that happens during the training stages. And then after that, even if some prompts go through, you can use some fancy words, use some words that may bypass the initial, you know, restriction. But then there is the main part that most of us, sometimes feel frustrated that why can't GPT, Claude, or some image generation online hosted models, why can't they give specific content? I mean, go, you can understand what I'm saying. There is a post generation filters. Even if the prompt goes through, when we get the image from the model, before giving it to the user, it does a scan. There are classifiers. So the classifiers are, let's say, it kind of a scanning method that Google has. It's very conservative model that Google has conservative classifiers. The classifier analyze it and then blur some of one. Blur is, I mean, they usually block it. Sometimes they may blur it, but it's very rare. They just straight up block it if they detect unsafe content. So there are some methods, you can use, reframe prompt, maybe open source. But usually when we are working with the nano banana, what I'm talking about is this. The main topic is this. When we are talking about nano banana, we're talking about the structure, the basic structure that we can't bypass. So one of the main reason is this model just runs on the server, so you can't really touch the safety layers that are classifiers that just block the content. And even if we do, we read from the prompts, even then, some of the content will not be able to go through. So what is the option? What do you want? Some person is writing a novel, or some you want to generate a movie, or some kind of drawing board for you know some kind of stuff. You can use the open source models and try to explain things in a very uh, try to frame the prompt in a compositional way that these things may then give you the output. But as we keep going through this, as more and more models comes, majority of the models that will come in the market will be from large corporations like Google, maybe GPT, maybe Anthropic may release it, even Quen. These models will be restricted, but there is a reason. I mean, there is a good reason for that. So the reason that it hurts the brand value. If some people are not really uh, good at using these technologies safely, they want to abuse it. So these filters will keep getting stricter and stricter as people may find ways to bypass it. So the prompt filters and the fine tuning and the post-generation filters may get more stricter in the future. Even GPT, which has now can give some kind of you know response that you may not get in a few years, or maybe even within a year, as they are trying to censor some things. So what is the solution? As first, to get to the solution, to understand the solution, what I'm telling about is you need to understand what's next in the LLM. What is the next stage? As now this is a very new technology, the images generation, and it's just started getting good. It's just nano, it's just the good model, the good quality model, the nano banana, which is currently the top model. It can generate thumbnails, stuff. So this is just the starting. It's just let's say we're just hitting a new curve. As more and more models comes, more open source models will also come, like Stable Diffusion, maybe Flux, and people will try to train their data on it. So there will be a lot more local model trainings, as these models will be more efficient at running in the local machines. If you have simple 3050 graphic card, computer laptop, or even 4090, I mean, it can, local models will become more efficient, and open source model will becoming, will start becoming more mainstream, as there will become increase, there's an increase of censorship. And as more models become mainstream, people will start training them in locally on their own data. So it's like an, I'd say, job is not really job, is, I mean, it will be like an assistant. Everyone have an assistant on their cell phone, laptop, that they now ask questions from chat GPT. First they provide some kind of context, Okay, for example, right now you will ask a GPT question that, okay, uh, right now, okay, this is the this decision I am having difficulty to uh, find a solution for. And first you will need to explain what is the problem. Okay, what is the problem that you're having right now, and the some kind of context with it, and some history that you wanted to the ChatGPT to know. I mean, this stuff, it's not safe. I mean, let me be honest with you. This is not safe. As more and more developers will become aware that how GPT uses their data, they will start training open weight models. And as open weight models become more mainstream, they will start in integration with their local machines or cell phones. I mean, this cell phone stuff is just still pretty far away. I mean, let's say maybe in a few years, let's say at max, you know, Android model, maybe um, let's say I think it will take a year or two. Maybe it's too fast. Yeah, it will take few years. But the problem with the local training, and then people will start, searching for stuff. How do we do this? How do we do that? So you need to be ahead of the curve and start understanding this stuff when it's early stage, so you can get benefit of it. And there will be a lot of new types of jobs. As you know, right now there is a lot of layoffs in tech, and a lot of law, policy changes. So there may be a new way of jobs. I mean, jobs will not go away. I mean, programming is just not just copy pasting stuff and copy pasting code. It's about thinking. So as new models will get integrated with the cell phones and your local machines, the thinking pattern will try to adapt to things. It will change. The things will change a lot. And as every application that you use will keep integrating AI, you will need a local model to balance things out. We can't really be using, Notion AI. I mean, everyone is launching their own. It's everyone is just creating the same thing. But I think the future is this: the more local model, like personal assistant, and as there is a rise of robotics, it will also get integrated with that. So I think this is a really good time to get understanding of these things so that you can start to work with it and start getting the benefit of things that are still in the early stages. So some of the overview of things that the concepts that we will be understanding in this live streams, or maybe some you know few hours videos that we will launch. I mean, this is not really a course, but it's like me documenting my journey and me trying to explain things, like teaching my own learnings, so that I can get a feedback and also let people know and maybe help them in some way. So this will not be a very linear course. So uh, that is maybe some kind of drawback, but this will be not be a linear course, as I don't believe in that kind of thing, that it will go from 0 to 100. This is very complicated stuff. You can't really go from tokens to system buildings. I mean, I it's not gonna make you like the learnings. If you're in college, if you're on some kind of course, yeah, then this can work. I mean, this can work. This very well can work. But if you want some kind of a few hours during the day, 2 or 3 hours, then this method may not work. So the best method will be, let me show you some explanation. So first of all, you need to make this a mind map. So let's say today. you want to train an image model. Uh, Train an image model of a character, and train an image model of a character, and you don't know actually how to. So what do? You start working it backwards, like reverse engineering. So you want to create a model like an Nanobanana or some kind of LoRa. So LoRa is a low adaptation model, like the open source models are all there. Okay, let me explain this. So LoRa's, for example, there is a open source stable diffusion XL model. These models allow you to train your own model on top of it. Okay, your own model on top of it. For example, this is a open source SDLX model, and then you add, let's say, you have 200 images of yourself, and you train this SDLX model using some methods like diffusion. I mean, there are methods to train it, and then what you will get is a LoRa. SDLX, and then let's say you name model. When you're using Nanobanana, you have to input your own image. Let's say you say this is my image. Uh, make me make this person do this, stand, hold gun, or ride bike. I mean, you can do a lot with Nanobanana, but these models allow you to do something more. For example, you just saved a um, person holding gun or standing near river side cabin. Just this, it is trained on your data, so it will just create images of yourself, of your image. But this is the tricky part. You need a lot of compute to do this. I mean, it's not easy. You can't just start doing it. You need very high quality images that you can only train up your own images, as you will have images of yourself from all the angles and very high quality. So I mean, this is tricky part, but it can be done if you have compute. So how I was saying, so you need to work it backwards. Just say, okay, I want to train a model on a character, but no harm. Use search for open source models and check how to train model, and then it still won't be enough to the Nanobanana, and then you will start, understanding these stuffs like model adaptations, prompting chains. So first of all, as you're doing this, for trying to interact with the open source model, trying to set a system where the prompts can generate images, you will come across these topics, tokens, neural networks, embeddings, and then what you can do is while you're training it on the training, then you have to make a mind map. So you take notes, you say, okay, I did this, but I came across this topic, uh, token. What is it? Then just make a file of it, and you start exploring this, like the token is this, that it does these kind of things. Okay, that's okay. You understand token. What is token? You understand it, and then you come, what neural networks? You don't know a thing about neural networks. And what do you try to do? Okay, so I'm training a model, and to train the model, I need to understand the neural networks, and we came here. So neural networks, and you will while you're understanding neural networks, your focus will be how to use this to generate or train your model. In this way, you will understand this concept way better than just trying to watch hundred of videos on neural networks, how it works, how to generate it. Your focus will be how do I use it in this. In that way, your learning will be focused. So same goes for this embeddings, attentions, and transformers. Now we will keep getting deeper and deeper as you're making progress. So it will not be like, okay, you understand this, then you go there, then you token, then accidentally start, neural networks. You will understand it, make some kind of progress, let's say even 1% progress. It still is moving to the right direction that you want to model. Ready, final model. But you know if you start learning in this way, okay, I want to understand LLMs and I want to learn AI. So you will go to some course and they will try to teach you stuff like a foundational concept. You need to learn this attention transformer. You will be reading a lot of review papers and a lot of research papers without any goal of using them. I mean, this will not be remembered for a long time. I mean, this will not be used if you don't know what is it used for. But when you're learning for a specific purpose like this, like we will be in a live stream, we will focus on the concepts that are useful. I mean, this AI stuff, it's pretty wide. I mean, you can't really do that if you're not have a good computer science background. So I don't have a computer science background, so I will be doing this method. I mean, it's good. It's try tested. I mean, you want to do something, you can't really be knowing everything before you start doing it. So there is a lot of stuff that you need to understand. If you want to understand the basics first without getting your hands dirty, this not if you're going down this road, this will take a long time. I mean, this if, because when you're doing chapter by chapter without any goal, what you're doing is you just keep you know spiraling out of control. For example, you're trying to understand vector search, but your goal is trying to create an image model. You will branch from here and you will be reading something that has no relevance to the current model we're trying to make. So this can be pretty negative. You can lag behind a lot of things, and this maybe seems like a fast method, but it's not. It is effective, yes, it sure, but it's not fast. I mean, neither is this. This may seem fast, but it just does not have any real usage to you. It will be like you just wasted 2 months, 3 months of your time with no really output here. But when you're doing this, you will read articles, you will come across problems, because this is actually just problem solving. And what you will be trying here when you're trying to learn these all together is you're not trying to solve a problem. You're trying to teach yourself everything so that every problem that came across to you, you can solve it easily. But it doesn't work like that. So we will be following this method, and I mean, we will be covering some of these things like RAG fine tuning and how to enforce safety as you don't want to use as you don't want others to use your own personal model for any misuse. And system, this is an important part, because you're going to use your model in a lot of ways, so the system will building will be a lot of more important part. I think that's it for today, and we will start the next video with, oh yeah, I just want to show you. Have a file like this. So I'm currently using Obsidian. It's just a simple note-taking app. So have a simple one-page note like this where you have all the resources, and so whatever you have, understood about things. Like I was started Nano Banana, and my main focus was how understand image models and how can I replicate Nano Banana, and then I made this, you know, note. So it is more important to also make notes, like a reference things, and then also kind of make a roadmap. You know, for week one you wanna do this, you wanna gather data set for training images and all the stuff. So you need to have one file. So you can't really be relying on this simple method. I mean, it is useful. So the Obsidian lets you, add these Excalibur files. For example, this I added this. Just click it. Oh, yes, I'm here. So it is useful. You can try it. Just download Obsidian and then search for Excalibur or a plugin, and you'll be started with it. So that'll be all. And